Today's pattern might be the simplest to understand, the facade. When you have a complex system with dozens of classes, the facade gives you one simple front door. Like calling a restaurant to place an order, you don't negotiate with the chef about ingredients. You don't talk to the delivery driver about routes. You don't discuss payment processing with the accountant. You talk to one operator who coordinates everything behind the scenes. Imagine you're building a video conversion feature. The underlying library is powerful but complicated. It has video file for loading files, codec factory for detecting formats, MPEG, 4-codec and OGG codec for compression, bitrate reader for data processing, and audio mixer for fixing audio. To convert a single video, you need to use all of them in a specific order. Get the order wrong and you get corrupted output. Without a facade, every part of your app that converts a video does this. First, you load the file and extract the source codec. Then you handle the conditional logic for different destination formats. Next, you read the bitrate and perform the actual data conversion. Finally, you mix the audio and fix any processing errors. 6 classes, multiple steps, specific order, conditionals for codec selection. Anyone who wants to convert a video must understand all of this internals. If the library updates its API every call or breaks, the facade wraps the entire complex subsystem behind one simple method. The caller doesn't need to know about codecs, bitrate readers, or audio mixers. They say convert this video and the facade handles the rest. Like that restaurant operator, one call, everything handled. Here's the facade. Inside the class, we encapsulate all those messy steps. We handle the file loading and codec extraction internally. The bitrate reading and conversion logic is also tucked away here. Finally, we fix the audio and return the finished product to the user. Before, 10 lines of complex setup, after, 1 line. The entire workflow is hidden behind one method. Here's a more practical example. An e-commerce checkout that coordinates 4 separate services. We have inventory, payment, shipping, and email services all needing to work together. Inside our checkout facade, we initialize all these services as private members. Step 1, we check if the product is actually in stock. Step 2, we process the payment using the provided card token. Step 3, we generate a shipping label for the customer's address. Step 4, we send a confirmation email with the new order ID. The client code is beautifully simple. 1 call, 4 subsystems coordinated automatically. The caller knows nothing about the internal complexity. So when should you use the facade pattern? First, for providing a simple interface to a complex subsystem. To reduce coupling with third-party libraries, wrap the library in a facade. And to organize a subsystem into layers, each layer can have its own facade. Important point, the facade doesn't prevent you from using the subsystem directly. When you need the full power. It's a convenient shortcut, not a restriction. Power users can still access the raw subsystem when needed. That's the facade. Simplicity in front of complexity. Next, the flyweight pattern, which saves memory by sharing data between millions of similar objects. See you there.